All right, so today I'm going to be talking about the Apollo VSCode extension. Now, I think we've seen this already a lot today. So in Jeff's presentation, in Peggy's presentation, we've already seen it. So today I'm going to be going kind of more in depth with how you have to get set up with this extension and all the features it offers you. So first, hi, I'm Shadaj. I'm a freshman at UC Berkeley, where I'm studying electrical engineering and computer science. As Jesse mentioned, I was an intern 2 times at Apollo. Some things you might know me for, the Apollo Client 2 Cache API, which is used by Hermes. So that's something I developed in my first internship. And then recently, I've been working a lot on the Apollo CodeGen and CLI. So I added things like Scala support to Apollo CodeGen, and then I worked on things like bringing the CodeGen into the CLI and a lot of the new features there. And Apollo VSCode. So that's something I worked on this summer, and I'm super excited to share it with you. So introducing Apollo VSCode. Now, this isn't something that just I worked on. There are a lot of people who helped out, and especially after my internship in bringing this to the finish line. So thanks to James Baxley, Martin Walraven, and Trevor Shear for really helping make this extension as awesome as it is. So what is the purpose of the Apollo VSCode extension? There are 2 primary goals here. You want to make writing GraphQL faster and smarter. So faster, that's like any IDE extension. You have code completion. You can provide maybe some snippets to make writing common patterns in GraphQL fast. But I think the really cool thing that we're able to do with GraphQL is we're able to make this process a lot smarter, where writing GraphQL isn't just dumping a bunch of fields into a file. You have to make decisions about it. If you have multiple ways to get similar sets of data that might have different impacts on how you render it in your client, you might want to know, oh, this field is going to take a lot of time to get from my server. So I may want to do that only on the web client, but on a mobile client where people expect much snappier experiences, I want to use the field that's a lot snappier to get from the server. So what does Apollo VSCode give you? It gives you code completion to write GraphQL queries faster. And this is something we've seen. Basically, anywhere you're writing GraphQL, you will get code completion. That's something we've really focused on. So if you're writing fields that take parameters that are enums, we'll give you code completion for the enums. If you're writing mutations, we'll give you code completion there. Anywhere you can think of, you get code completion. We give you automatic linting. So as we'll see in a bit, Apollo VS Code is actually built upon the foundations provided by Apollo CodeGen and Apollo CLI. So any type of GraphQL linting that you have in those tools automatically comes over to the IDE integration. You get quick navigation. So if you're working with large code bases, it can be really hard to understand, oh, where's this fragment coming from? Or I have this fragment. Where is it being used? Is there any point in having this fragment in my code base anymore if all the devs aren't using it anymore? So you get quick navigation to understand that. And you get inline performance stats to minimize context switches. So with Apollo Engine, you can know exactly how fast your query is going to run based on data from your real live production app. And you can make decisions based on this to understand what type of queries you want to be performing. So let's do a live demo, and hopefully everything will work. So I put together a to-do list so that I don't forget to demo some parts. So let's start by writing a my query .graphql. So let me zoom in on this, because this is. So here, I have a simple GraphQL file, and we can start writing queries. So I can start by writing a query. I can name it my query. So here, I've configured the Apollo VS Code extension to run against the GitHunt API. So GitHunt is a demo app that we developed at Apollo. So here, I don't remember. I totally forgot what fields are in this, so I can just hit Control space, and now I know exactly what's available. So this is kind of your first step of using the VS Code extension. So I can say, OK, I have my current user, get me their avatar. But I can do even more things. So for example, let's say I want to get an entry. Now it knows that repo full name is actually a required parameter for this entry field. So if it's optional, it actually will directly take you inside those curly braces. But in this case, it knows repo full name is required in order to query this field. So it's going to generate code to type that in. So I can type in Apollo GraphQL / Apollo client. Now I can say, OK, what's available on here? I could get the comment count. Oh, now we have some stats. So now we can see here that on average, the entry field takes 193 milliseconds to query, and the comment count takes 606 milliseconds. So I might want to consider maybe not querying the comment count, because that's going to take some time. But let's say I want to do that, and then I can get comments, I can get the content, I can get the repository, and I can get the full name of that repository. And so in just a couple of seconds, we were able to go from not knowing anything about the schema that we were dealing with to being able to write a query against it, because we're able to understand at every stage exactly what data is available for us. So OK, we wrote OK, so now let's write a fragment. So fragments are a really powerful tool in GraphQL for two reasons. One, they allow you to reuse different field sets that you're going to need to query. And two, they work really great with statically typed systems. So if you have a fragment, that fragment can have a type of its own. So then you can share that type of data and that data model across your application. So let's write a fragment for comments and name. So now I can say, oh, I want this to be on a type. Now, what type do I want? So as I mentioned, we've really made it a strong focus to make sure that code completion works everywhere. So here I'm writing a fragment. It knows that after on, you have to pass in a type that that fragment is going to be performed on. So I can say, oh, this is going to be on an entry. And now inside here, I can say, OK, I have my comments, I have the content, and I have my repository. And I have the full name. So now I can just replace this chunk with ... And now it code completes, because it knows that I'm inside an entry, so all the fragments that are available on entry can apply, and so I can code complete. And I have this query. So now that we have a query, we can play around with this a little more. So if I want to jump around and kind of understand more about my application, let's assume that comments and name was in a different file, or we can move it to a separate file for now. Comments fragment.graphql. So I have this fragment. I have it here. Let's say I want to know where this is. So first of all, if I hover over it, it shows me the source. I can also jump to this. And this works no matter how large your code base is. The way the extension works is it actually scans all the GraphQL files throughout your project and then looks at all of them at once. So even if your fragment is somewhere far out in your application, it'll still be able to find it, and you can jump to it and understand exactly what's going on. Now we can do a couple more things. OK, validation. So let's say I write current use. You get validation. Relatively straightforward. So now you can make sure that all of your queries are going to run. We actually do a couple more things. So for example, if you forget to put your name, Apollo actually doesn't support anonymous operations when you're using with the CLI or if you're working with engine tools. So we'll make sure that you're following this best practice of naming all of your operations. It also makes sure that you're compatible with tools for generating static types, where the static type names are going to be based on your query name. Performance stats, we've seen before. Basically, anywhere that you have data from Engine available for those fields, you'll be able to see them. And these stats are always updated live based on whatever Apollo Engine has received from your traces from your production server. And schema navigation. OK, this is really awesome. So let's say you have a field, and you want to explore more things related to that field. Well, in addition to being able to jump to fragments, you can also jump directly to your schema. Now, I actually don't have a schema file in my entire project. I got it from an introspection. But what we're able to do is we're able to reconstruct a schema file as if this is what you wrote when you were working with your server, and you're able to navigate it. So you can see, oh, what else is available on my user? I have the name of the user. I have the URL of their GitHub page. I can see everything that's available in this schema. And this is live generated based on the results that you get from Apollo Engine or your local server introspection. And finally, and Peggy talked about this a little bit, we have support for client-side schemas. So let's say I write a client schema.graphql. No, there's no config required to set up a client-side schema. All you have to do is say, I'm going to extend a type. And now I can extend, let's say, the entry type. And then I can add local field. Field is going to be a string. So now, the moment I did that, now I can see, oh, something broke. Oh, no. This isn't great. Let's see. I'm in my entry. OK. OK, here we go. There we go. So now I can say local field, and it shows up. And this is without any configuration required. So we're actually able to automatically scan all of your GraphQL files. If we detect that extend type, we're automatically able to stitch that into your server-side schema. So then those fields are available wherever you want to query them. So that's it for the live demo. Things went pretty well, I guess. So a little bit of what goes on inside. So you have your VS Code extension. What we've done is we've designed this so that the VS Code part of this is actually a very thin layer on top of a larger Apollo language server. And so what you're able to do with this is, if you want support for Atom or Emacs or IntelliJ, all you have to do is just talk to the language server, and the language server can be reused across every IDE you want. In addition, your Apollo language server actually talks to the Apollo CLI. So we use the CLI as this foundation, which handles things like getting your schema, running validation, And so we're able to build upon this base that's used for handling all of the tooling across your projects, and we're able to integrate this into your IDE. So get starting today is really easy. You install the extension, and you add your engine key. What does adding your engine key look like? It's as simple as this. So you specify what your service name is, you specify what your API key is, and the moment you hit save, if you have the extension installed, you'll get code completion automatically in your IDE. And also here, I use GraphQL files. It also works with TypeScript, JavaScript files if you have your GraphQL tag installed. And also, I hope you all contribute. So as I mentioned, this is based on the Language Server Protocol. So if you're looking for integrations with Atom or other IDEs that you like, please contribute to the Apollo tooling repo, which now contains the CLI, CodeGen, and our language server. All right, so that's a quick overview of what goes on with the Apollo VS Code extension. So I hope you try it out, and thank you.